How's it going, guys? Good. It's a crazy week. So I'm going to demo the Oculus on Thursday. I didn't have time to get it together and make sure it was working. My luck, I'll bring it in here, turn it on, and it'll want to do an update or something. So I didn't have time last night to deal with it. So we'll do that on Thursday. And then I'm going to pick up the gear. I'm going to try to pick it up after this class and get it to my office today. Actually, you know what? I didn't bring my case for it today. I'll have to get it on Thursday instead. So I'll go over there and talk to the guy though, so that he has it ready for me on Thursday. So after class, probably right afterwards, go over there and grab it. Okay. Yeah, so that'll help probably because then I can bring a couple of cases for it. And then what we'll have to do, I don't know, I won't know until probably later today if I have to go to San Francisco on Friday. I'm saying it's probably a very low chance, like probably less than 5%. But if I get told I need to go up there, then I have to go up there on Friday instead. I'll just get you guys equipment on Thursday. Whoever has the 8 a.m. class will have it, and then you guys can coordinate how to get it from each other throughout the day on Friday. Matt's, I think it's Matt's section that is going to be the following week, yeah. So I think we're all good on that. And then I sent that message about there's some people that aren't in a group for some reason. Yeah, right? So I guess what we'll do is, we'll just add them to, well, I think we'll just have to create a new group for those folks because there's enough of them to make a new group, 52, because there's 51 groups right now. So I think we'll just have to force anybody else that says they don't have a group in a group, and they don't get credit for the minutes today, and they don't get credit for the minutes last week. They've lost those points. So if they want to make them up, they have to do extra credit labs. Yeah, it's only fair. Everybody else turned them in, so. Look at it from the perspective, you can grade them whenever, but it's basically, did they make a good faith effort to do the lab? If they made a good faith effort, whether they got it wrong or right, I don't care. It's just, did they try? Yeah, it's your discretion of, based on what the lab was looking for, did they make a good faith effort to do it? Yeah, I haven't created the box for that yet. I think I posted that I would do that in a couple weeks. So they just hold on to the labs, extra credit labs for now, and I'll probably have to do like one box and make it where they can submit 14, however many extra credit ones there are. And we'll just have to have one box for all of it. It's either the full points, which are in the syllabus, or if they didn't do it, if they didn't make a good faith effort, then they get 0 points, basically. Yeah. Yeah. I mean, if you want, I think it's more complicated to do like smaller. I think it's just either pass or fail. You either got full points or not. It encourages people to actually do it because they're not going to learn if they don't actually do it and don't try. I don't care if they get it correct or not because it's not a correct answer thing, right? Did they make a good faith effort? And you guys make your own judgment on that. I would be doing the same thing. So, yeah. That's what I always grade labs pass fail for that reason because someone gets stuck on it, but at least they tried and at least they made a good faith effort on it. Yeah. So. Cool. All right, we're gonna get started. Yeah. Okay. Okay. No, you should do it today. Yeah. Yeah. For week 1. So you need to get it in today. I mean, I have office hours at this, so you can actually bring it to me. But I'm leaving campus today at probably 1 o'clock. So if you can't do that, what you're gonna have to do is turn it at the undergrad office with my name on it, and make sure that they know that it's for me, and then they can put it in my mailbox, and I'll check my mailbox on Thursday for it. Yeah. It's the undergrad office is right outside my office. It's where you go for like if you need to add a class to the schedule. It's the office. Just give it to the front desk. Ask them if they can put it in my mailbox for me, or put it in my office. Either way, but I think it's gonna be less likely to get lost if it's in my mailbox. Okay. Mm-hmm. Yeah. At the end. And if I'm starting to leave the room because the other professor's in here, just meet me out in the lobby there. Find me in the lobby. I'll stick around for a couple minutes and then I'll head out to my office hours. Okay? Okay, groups, bring your minutes up, please.
When you start class, can you announce someone missing their phone? Like someone just left it on the phone outside.
Okay. Is somebody missing your cell phone? Is anybody missing your cell phone? Be prepared to describe the cover thing on it and what carrier it is. Okay. Nobody? Okay. I guess I will take it to the undergraduate office and report it as missing to them. Yeah, it might have been someone from the other class. Yeah, so, yeah. When? Today? Oh, I actually canceled that because yesterday was a holiday and I wasn't available, so I replied with a cancellation. Yeah, so it's all good. No, I just canceled it because I had to take yesterday off. Yeah, I worked all weekend. I had to take yesterday off. Okay. Mm-hmm. Yes. Okay. You mean your group didn't add you? Were you here the first week? Okay.
Discussion one, and then we were texting each other. Was seeing if I can make a schedule. But the last week they said they text me that I couldn't add you. I have no idea why.
That's not the case. We aren't changing groups. You're still in that group. So what I suggest is send me their names, and I'll reach out to them and let them know that we're not changing groups at this point. It's too late to change groups. You just have to be part of the group.
No, it's like they didn't put my name on the minute sheets, so I couldn't.
So you didn't sign the week one ones last week?
Signed up. I mean, they didn't put the member list at the first week.
Okay.
So they continued to the week two, and they text me like, we couldn't officially add you.
Okay. After class, are the people in your group in the room right now where we can talk after class? Because we're not going to change groups. We got to get people in the group that you're already in. There's 300 students in this class. I can't be switching groups at this point. It's too difficult. So at the end of class, can you find, I don't know where they're at. Can you find them in the class here? Do you know where they're sitting? Anybody from your group? And I'll talk to you all after class because I have to get started, but I can talk to you all after class and work this out and figure out what's going on. But the groups have been assigned and everybody's working together. You guys picked groups already, right? You picked your. Mm-hmm.
We haven't submitted shit yet. We haven't just put down all the numbers there on the sheet.
So you guys haven't turned anything in yet.
So we have to officially.
Can you give me a name of someone in the group so I can call them up here? Do you have contact information for anybody? Is there a Jose Barragon in the room? There's a Jose Barragon. Can you come up here, please? Oh. Okay, so we picked groups a couple weeks ago. We can't change them now. So he said you guys agree to be in a group together.
Great. Well, I told him that me and my group I never. So there's a bunch of people. So you guys didn't agree together? Was that what happened? Yeah, we never. I never said that we would. He asked if he could. I said that I would talk to my partner about it. And my partner sort of like he asked me to do it. So then that's what I explained to him. But then that's when I gave him my number and my email and asked me if I could just. Well, I never heard of it. So you guys your minutes and everything? Yeah. And he wasn't on there. He wasn't on there. So go over to like the TH over there and talk to them. We're going to create a new group. And so each of your advocates is going to be else. I know my name's not you're probably going to have most of the names. I probably won't excite you. If you're on reading lists, then I can add them. No problem. It's just okay. I just want to make sure that we're not keeping people out. Yeah, we're not keeping them. It's just that he was really confused, just like that.
All right. Let's get started, please. Quiet, please. Okay. Still loud in here. Please get quiet. Okay. 2 things we're going to cover today. Okay. Hopefully we have time. All right. First of all, I'm going to go into data communication. It's a little bit more boring, but it's very important. I'm going to show you with a few volunteers some examples of data communication. Okay. And then on Thursday, I'm going to bring in the Oculus Rift. We'll hook it up to the screens, and we'll go on a virtual tour of the world and explore some other things that will be useful in business. Okay, yes. Chapter 14 is going to be today as well. I'm going to start with chapter 6, though. Yeah. Okay. So chapter 6 and chapter 14 for this week. All right. So before I get started, at the end of class, if you haven't turned in your minutes, please do so. Okay. And if I have to leave the room for the other professor, I'll be out in the lobby for a few minutes after class to collect these. Okay. Second thing is, if you don't have a group, you will fail the course. See our TAs to get assigned to a new group. Okay. If you are not in a group. If you're in a group, you're stuck in that group for the rest of the quarter. Okay. We're not going to change them. There's too many of you. I will go crazy. I spent all day Sunday fixing the groups in iLearn. I don't want to do it again. You can't change groups. Yeah. No group changes. But if you did not end up in a group for some reason, you need to see the TAs before you leave today. Okay. If you do not, you will fail the course because you can't get enough points without the group. Yes.
Right now we have situations that one of our the group members, the time, the availability is different. So.
Well, that's why I said choose based on availability in the first class. So if you have that problem, you're going to have to break your group into 2 smaller groups for the purposes of meeting, but come back together and discuss, okay, if that's an issue, right? Something I can do in a class of 40. It's not possible to do with 300, okay? Yes? That's probably because I couldn't read a name and I guessed. So email me or send me a Slack message with the name that's not supposed to be in your group, okay? And the name that was supposed to be in a group, okay? Make sure things are legible. If I can't read it, you're not going to get credit, okay? Prime example probably. All right, so data communications. All right, so today we're going to talk about data communications, networks, core network concepts. Some of this material I'm going to talk about, though, in the slides during class is not in the book. The book doesn't talk about it, but it's very important. So DNS, not in the book, okay? But it's very important. The good news is the test is only about what's in the book, okay? So you don't need to worry about it for the exam, but it would be very helpful in your careers to know this stuff, okay? So at the very least, you probably want to take some notes. IP addresses and DNS, wireless and mobile networks, and then encryption, okay? And the encryption piece will be something that I will talk about. I don't know that we'll get to the demonstration part today, but we definitely will do it on Thursday, okay? And I will say for that demonstration, when we do that, it's participatory with the audience. Please don't write like secret messages you'd be embarrassed about, because I'm going to demonstrate how encryption works, and that means I can see what you write, okay? So I've had a student get very embarrassed by me reading the message in the past, so beware. All right, so data communications is the electronic transfer of data from one location to another, okay? So the way that networks work are, we have bits of data, okay? And that data is transmitted from one place to another over some sort of networking medium. So in the class here, none of you have wires connected to a wall jack, okay? We're using the wireless things that are in the ceilings above our heads, okay? That's how we connect. We use a wireless network, but we might also use a wired network in offices. So the components of data communications, we have a device to send and receive data. So that could be our phones, our laptops, our desktops, even servers. There's network equipment, routers, wireless access points, switches, firewalls, okay? In this room, off the top of my head, I can only see 2 wireless access points in the back of the room. I don't see any. Oh no, there's 2 up here in the front too, okay? So we have 4 pieces of network equipment in the part of the room that we can see, and I'm sure that there's more network equipment in that little booth up there that none of us have access to, okay? The little secret space, okay? Telecommunications media, either wired or wireless. So wireless is pretty easy for us to understand because we all use it on a daily basis, okay? It's using radio waves. Wired, on the other hand, can be many different types. What we commonly see is copper-based wiring. Looks like a phone wire, if you remember what a wired phone telephone looks like, okay? You might see jacks in rooms for that, okay? That's a wired medium. But there are other forms of wired mediums like fiber optics. Does anybody have fiber optics internet to your house? I do. Okay. That's using light rather than electrical signals. Okay. Bandwidth. Most of us today have broadband. Does anybody still use a dial-up connection? You'd have to be in a pretty rural location to have that still. Okay. Narrowband would be, dial-up would fall into that. Okay. Mostly rural areas, most of the US is covered by broadband now. Some of it's not very good broadband, but at least it's broadband. Okay. All right, telecommunications media I mentioned, copper wire, by far the most common of what you would see in, say, a home or office. Okay. How many of you have cable modems at home or cable internet service? Anybody? That uses coaxial cable, a little stiffer wire, okay, harder to bend it, but still electrical signals. Fiber optics uses light, okay? It's made of a form of glass, okay? And then we have wireless, and we have many types. We have cellular, which is what we all use when we're not on a Wi-Fi connection, okay? There could be broadcast wireless where could be things, either a Wi-Fi network like we have in the room here, could also be what's called line of sight wireless, which is basically an antenna or a satellite dish sitting on top of a building, pointing to another dish 5 miles away or whatever it might be, which then picks up the signal and distributes it to that local area, okay? So in rural areas, you might find the fixed or line of sight wireless where it's not feasible to run cables. Okay? Spread spectrum, another type of wireless. Satellite, okay? Satellite's another type of wireless technology, okay? Satellite does have some limitations. It takes a long time for the signal to get between the Earth and the satellite up in space, relative to any other technology. So how many of you game? Okay. They want to admit it. Nobody wants to raise their hand in this class. It's too intimidating. But if you game, you probably wouldn't be able to do gaming over a satellite. There's too much of a delay between the time it leaves your computer to the time it gets up to the satellite and to the server where the game is. It wouldn't work very well, okay? Microwave, remote areas or businesses might use a microwave antenna for doing network access as well. And then another form of wireless is infrared, okay? So actually this is a good example of infrared, okay? This is, actually, you know what, this is using Bluetooth, I take that back. But a remote control for a TV is an example of an infrared data device, okay? All right, so we start off with the OSI model, and this is a good way, and in the book it actually has a graphic, so the slides here to remind you of the different layers, because this probably will be a test question. I don't really remember, but this is part of the book, so it could be fair game. The OSI model is a good way to look at networking, okay? So in the book, there's a nice little graphic that shows a person connecting to the internet and how the OSI model is involved. The physical connection, so either our wireless physical connection, even though we're not actually physically touching it, there is a connection there, that fits into the physical. And we move up to data link, network, transport, session, presentation, and application. Okay? The application being where we have things like our web browser and web servers and things like that doing communication, or a database server, okay, connecting to that. Okay? But the OSI model is how we break down how things work. And so every time, even as I'm speaking now and I'm streaming to YouTube, okay, every time I say a word, it's going through these different layers, going up to YouTube and coming back, okay? I want to make sure it was actually recording. You've had problems. All right, so networks. Local area network. That's what we're on in this room, okay? It's within this particular campus. If we have a house and we have an internet connection, we're on our local area network while we're inside our house. Our TVs, our phones all connect to our internet there. Okay? A wide area network is multiple LANs connected together. The internet is one type of a WAN. It's a very big WAN. Okay? The internet is just effectively millions and millions of LANs connected together. Okay? And we're connected together through services like cable, DSL, fiber, cellular, whatever it might be. A metropolitan area network, or MAN, is a network that you might see in business for a larger company. Okay? Let's say I'm a big company and I have multiple office locations. We might connect them together using a metropolitan area network. It's faster than a WAN, and it basically means our offices have some sort of private network connectivity between them. Okay? Generally speaking, most of us are only going to ever encounter the first two. Okay? We all encounter both of those first two. Okay? But if you work for a larger company, you might encounter the third one. Now, there are different network topologies. Okay? And we have things like the star, the ring, the tree, the bus, and the mesh. Okay? And assuming I brought my scissors, well, I'll just give you a preview of what we're going to do next time then. So I've got this big ball of yarn. What we're going to do is demonstrate these different networks, because you'll see why we can't do some of these network topologies. They're not feasible. If we're doing wired connections, we would never do a mesh network, because every single one of us would have to have a string connected to each other, and every other single person in the classroom. You can imagine that would be a huge mess, okay? So we see mesh networks sometimes in wireless. Not this type of wireless, by the way, okay? Although we could. Generally, if you've got a smart home, you probably have devices that connect to one another. Each device that you add to your home extends the span of how far that network can talk, okay? And it improves the network. We wouldn't be able to do it with our string here, okay? Now, most common is the bus for wired networks, okay? Bus, boom. Okay? Star and ring really aren't used that much anymore. And I can't say that I've ever seen a tree in my entire business career. I have seen star and ring a long time ago, but they pretty much gone the way of the Edsel. Okay. Bus networks are basically all the devices are connected, but not to one another. Okay. So They're connected using network connectivity, network devices, but they're not directly connected to any other device. Okay? So we use things like switches, which are a form of network equipment, to connect these networks together. Now, some other concepts that we need to understand are TCP/IP. That's the protocol. Okay, protocol is like a language. Let's take a step back. Okay? Computers don't speak English. They don't speak Spanish. They don't speak Chinese. It doesn't matter. Okay, they don't speak anything like that. They have their own types of languages. Okay, so same with a network has its own language, and we call those protocols. They're just like a language, though. We agree on certain concepts and certain ways that we construct things. Okay, so TCP/IP is the agreed upon language for the way that networks like the internet operate. Okay, and it uses that thing called the OSI model as part of that protocol. Okay, that helps you to understand how this protocol works. So one of the other concepts that's involved with networking is routing. Okay, and by routing, I don't mean woodworking routing. Okay, when I was trying to explain this to my dad one time, he thought I was talking about this little thing that I guess cuts wood. Okay, nothing like that. Routing is like taking a road trip for your data. Okay, we want to go to the airport. Our map application gives us a route. Okay, and it might change to the route depending on traffic. Network routing is the same thing. Okay, we decide that we're going to take a trip and go visit YouTube. Okay, each of us in the room could all go to YouTube. Please don't, by the way, it'll screw up the streaming right now. Okay, but if we all went to YouTube at the same time, chances are we would all go on different paths to get to YouTube. Okay, through the internet. The first couple of people might end up on the same path, but as soon as we all start hitting it, it's going to cause the network to reroute us to the most efficient method to get there. Just like if we all got on the road right now, Waze, Google Maps, whatever you use is going to start routing you different ways. Okay? Now, on that road trip, just like our car, we can think of packet as a car. Okay? The packet is where we pack all of the information that we're going to take. And so a packet is a small unit, just like our car. We can fit a certain amount in our car. Okay? And if we can't fit everything in one car, we have another car or another car. Okay? So those packets collect the data, which when we talked about the database unit, we talked about bytes and characters. Okay? Those packets consist of the bytes. Okay? Now the routing tables of how we get from place to place are generated automatically by software. Okay? And the software sits on these devices called routers. And a router, you can Google what they look like. They're just, they look like a little pizza box. Okay? And the servers all connect to them. Our wireless access points all connect to routers as well. Okay? If you have a DSL modem or a cable modem or a fiber optic ONT box, those connect to a router as well. Without a router at home, we wouldn't be able to get on the internet. It's a key piece of hardware. Now, what we have at home is vastly different than what the university and businesses use. Okay? What we have in our home is a little piece of plastic. Okay? It can support our house getting on the internet. It would not be able to sustain this entire classroom. Believe me, I was sick one time. I still did class for a group of students, and I only had 50 students. And they all connected to a device in my house for a lab. It killed my router at home. It actually started getting really hot because it was running too hot, and then it actually fried it during my class, so it didn't work so well. The university uses very high-end equipment with special configurations and hardware to support thousands of people simultaneously, okay? Which means it's very expensive. None of us can afford it, unless you're a millionaire in the audience. Right, systems architecture. I'm going to explain this a little bit later, but I'm going to use a whiteboard software, which will allow me to show it in class, and we'll draw on the screen, and you should all be able to see it. Okay, I'm going to skip that for now, and we'll come back to it. Wireless networks, cellular and mobile. Okay, they're radio-based. At its core, a cellular phone is a radio just like the radio in your car. Okay. Except the radio in your car doesn't transmit, it only receives information, okay? Your cellular phone has an antenna. We don't see the antennas anymore, but they exist. Old cell phones, you had an antenna that you pulled out. Okay, we don't have to worry about that anymore. Then we have these things that are radio cells or cell towers. Okay, and these are distributed around to cover a wider area. Okay. Wi-Fi, on the other hand, it is radio-based. It's usually faster, but it only covers a very small area. So these devices in the room here only cover this room. And I'd be willing to bet that the ones in the back probably cover the back half of the room, and the ones up here cover the front half. Okay. And the reason for that is if we all connect to the same device, none of us would be able to do anything on the internet. It'd be too slow. Okay. Now, the next thing here in networking is telepresence. Okay. And then after I get through these group of slides, I'm going to do some demonstrations of the networking concepts, and then we will go into the emerging technology, which is probably why so many people showed up today, okay, to see that. So first thing is Cisco telepresence. Has anybody ever heard of that before? If you're lucky enough to work for a company that has this, you are effectively feeling like you're in the same room as people anywhere in the world, okay? I have sat across from, say, the front row here at a table. It's all a screen, but you all look so realistic, I feel like I could reach across the table and shake your hand, okay? That's how realistic this technology is. It's also a lot of money. So larger companies tend to have it, smaller companies do not. So they end up using one of these other tools. Okay? But let me show you what this looks like. Save time and money before it's even turned on. No more major installations. Can be solved by just two people in a matter of days. One ordinary 10-amp circuit, one Ethernet port. And it's ready to go. That's right, this runs on this. Now imagine all the places and ways you can use an IX5000. At the core, one powerful engine gives you a better experience at lower cost and less bandwidth. Pumping out glorious high-definition video on the 370-inch screens. That same engine can handle 5 screens at the same time. Now, imagine what you can do with 2 simultaneous screens of rich media, and the audio sound like a Hollywood blockbuster. Meetings are never going to be the same. Executives move over. Every team is going to want this. The IX5000 is effortless to use. Sit down, stand up. The 4K cameras won't miss it. It's pretty cool looking. I've actually gone to meetings in them, so they're pretty cool. All right, so the next thing is WebEx. Has anybody used WebEx before? Okay. So WebEx, Zoom, Google Meet, and BlueJeans are very similar. Okay. They're all web conferencing platforms that we can use on our phones or our computers. So it's the telepresence for the rest of us. Okay. And so I end up in these meetings a lot. Aside from meeting with me, has anybody ever used these tools before for any purposes? Maybe some people. Okay. They're all similar. Okay. We all, the same basic concept. We utilize a network, we connect to someone else remotely, we share video, we share a screen, we share audio with one another. We can all talk to one another. It's very convenient for us, okay? So for your groups, if you're not able to meet in person, a suggestion would be to meet virtually using one of these tools. Google Meet is free. As long as you have a Google account, you can use it. Skype's another example, by the way, I forgot to put up on the board, okay? WebEx, Zoom, and BlueJeans cost money, so you would want to use those. All right, so I'm going to show some basic demos of some things on the board here. If you have questions, please raise your hand. Okay, it'd be very important. We're going to talk about some basic networking. We'll do some demos of LANs and WANs and stuff next class. We'll do IP addresses and DNS today. And then we might have time for data encryption. I'm not sure yet, okay? So let me show you some examples. All right, so on your computer, and it doesn't matter if you have